So again, we're talking about quadrilaterals. Today, it's going to be specifically parallelograms. The Common Core is G for geometry, CO for congruence, and it's number 11. And it's proving theorems about, and we're going to say parallelograms. Parallelograms, okay? All right, so I've got definition and characteristics because they're different, okay? So, I mean, the definition's as simple as this. It's a quadrilateral with two sets of parallel opposite sides, okay? So, just this definition alone gives us something. Parallel sides, okay? And that's important. We're going to find that knowing that this is parallel later on, when we do a proof, sorry, I got a couple of proofs to do, will help us out, okay? So we know that for sure, okay? Now the characteristics, so those are all the things we had in our theorems. Well, one of the things we know, characteristics, we know that opposite sides are congruent. Okay, we know that. That was one characteristic.
Opposite angles are congruent.
We also know opposite angles are congruent, right? We know consecutive angles are supplementary, right? Consecutive angles are supplementary, 180, right? Supplementary means they add to 180. I'll put 180 degrees there for you. So remember, supplementary is 180 degrees, right? And then we got one more. What's the last one? Very good, Kurt. Diagonals bisect each other, okay? Good. So then, this whole next week we're going to be talking about different types of parallelograms, like a square, like a rectangle, right? So when we have those, we'll say it's a parallelogram, and we already know all this stuff, right? Does that make sense? So when we do a rectangle, we won't have to list all this stuff because we'll say it's a parallelogram. We'll say, boom, if it's a parallelogram, all of these things are true, right? It's a rectangle, right? Okay, now, find all missing angles and sides. Well, that's easy. So right off the bat, easy. That's 12. That's 12. I know this is so difficult, isn't it? Can you guys believe this is actually a high school class? That's 8. That's 8, right? That's 64. That's 64, right? Does that make sense? Now, there's two ways to get the other angles. One is to add these two, subtract from 360, and divide by 2. But that's too much work. How about the fact we know they have to add up to 180? It would be much easier. So I'm just going to go 180 minus my 64, because consecutive angles are supplementary. So 180 minus 64, and I get an answer of 116 and 116. Thumbs up? Is that pretty easy? I hope so. That should have been easy for everybody, right? Okay. Now, if it's a parallelogram, that's 3. That's 3. That's 5. That's 5. Right? Because they bisect each other. Easy peasy lemon squeezy. Good. I'm going too fast or am I okay? Alright, number 2. Find all angle measures and the lengths. So first of all, let's get the lengths. These two sides of a parallelogram have to be equal. So let's just go straight and do a little bit of algebra. I know, sorry. Let's take a 5x plus 19 and set it equal to 7x. That's one thing I do like about this book. It makes you do algebra, so we don't forget our algebra. Okay, so if I'm going to solve, I'm going to go minus 5x, right? Minus 5x. 19 is equal to 2x. Divide by 2, what's that, 9.5?
Yes.
X is 9.5. But that's not the answer, is it?
No.
Yeah, let's plug it in. So let's take our 9.5 and plug it in. I don't really have to plug it into both. I don't, because they're equal, right? So if I get the 1, so just go 5. So I use my calculator. And go, okay, what is 5 times 9.5 plus 19 gives me an answer of. So this side is 66.5. And of course, this side is also 66.5, right? Now the angles are not equal. They don't even look equal, do they? But they add up to 180, okay? So I'm just going to take my 6y plus 5 plus my 10y minus 1 instead equal to 180 because they're supplementary. They add up to 180 degrees, okay? They're not equal. They don't even look equal, but they do add up to 180. Okay, how about a 16y plus 4 equals 180 because I combined the y's and I went to 5 minus the 1. Okay, if I'm going to solve, I'll go minus 4 minus 4, so I have a 16y equals 176. Divide by 16, oh no, it's 176 divided by 16, and I get 11. So if y equals 11, that's not the answer yet, right? Let's just plug that into here. So I'll use my calculator. What is 10 times 11 minus 1? 109, so this one's 109. And this one's got to be 6 times 11 plus 5, 71. There we go. Or I could have just subtracted from 180, right? Thumbs up? Easy? Okay, good. Good. Nice check, okay? Am I going too fast? Am I going too fast? Just a little bit. Slow it down a little bit. Oh, zoom in. You know, doggone it, once I start recording, it won't zoom in, Megan. I'm sorry. Okay. All right. Example 3. 3 vertices. So one's at 1, negative 2. Okay, there's A. Negative 2, 3. 1, 2, 3. There's B. And 1, 2, 3, 4, 5. Negative 1. There's D. Okay, now if I don't make this into a parallelogram, there are 3 possible points. 3. There really are. There are 3 possible points to make it into a parallelogram. The easiest one to find is right about there. Does that make sense? Right about there to make a parallelogram, boom, 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 right about there, right? Believe it or not, there could also be one right over there. Can you see my figure there? Can you see the other parallelogram there? Right? And then another possibility would be one way down here. There are 3 possible answers. Can you see it? The easy, we'll get the easy one, okay? The easy one's right about there. But for another parallelogram, you could have one way up here. Can you see that? Another one could have been way down here, okay? So there are 3 possibilities. But let's get the easiest one, okay? This is just find the coordinate C. So here's how you do it. It's a parallelogram, right? What do we know about parallel lines? Same slope, right? You with me? Same slope. So let's find it. So to go from A to B, I'd go 1, 2, 3, 1, 2, 3, 4, 5, right? So from D, I'd go 1, 2, 3, 1, 2, 3, 4, 5. It's got to be there. Has to be there. Parallel, right? 3, 5, 3, 5. So coordinate C's got to be at 2, comma 1, 2, 3, 4. But we're only going to find one. Possibly on your next quiz, your extra credit might be to find all 3. But that's actually pretty easy, isn't it? Because it kind of showed you where they were. All right, you ready to turn the page? Ricky, you with me? Yeah, okay. Turn the page, okay. Oh, a proof! Oh my goodness, seriously? Oh, I'm killing you, aren't I? Okay. All right, so if it's a parallelogram, I know a couple of things, okay? So 1, right off the bat, given, okay? A, B, C, D is a, and here's my little abbreviation for parallelogram. How do you like that? Given. All right, let's see if we remember anything, okay? With a little luck, we remember a whole lot of stuff. So what I want to prove is ABC. I want to prove that this triangle is congruent to CDA, this triangle, okay? All right. All right, there we go. See, you guys don't forget this. You guys, yeah, I totally agree with Kurt. Kurt's going to say right off the bat that AC is congruent to CA. Totally agree with him. Reason?
I said CB is equal to AD.
Okay, I'm going to use that next. How's that sound? Step 2. What? Okay, I
That's
just
reflexive.
reflexive. Okay. All right, now I'm going to do what Kurt said. Nice job, Kurt. So Kurt's now going to say, okay, I know that's equal to itself, right? Kurt's going to say this side's equal to this side. Step 3. We're going to say that BC is congruent to AD. Reason, we're just going to put op sides parallelogram congruent. How's that? That's theorem 621, but it's just easy to write it out, right? Okay, guys agree with that? Okay, great. What else?
You can do the same thing for A and B.
Yeah, we can use this one again. Actually, we can use the exact same one because let's just say AB is congruent to CD, right? Thanks, Claire. Let's put it all in one step, okay? So let's also say AB is congruent to CD, right? And the same reason, right? And I already did the AB or AC. Now there's even more you could put in here because you could have had angles equal by alternate interior angles. You could have said that angle's equal to that by alternate interior angles, okay? We could have said that angle's equal to that by alternate interior angles, but we didn't even need to say that because I have 3 things, right? What are the 3 things I have? I've just got side, 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 right? So we can go right to step 4. Triangle ABC is congruent to triangle CDA by side, side, side. That was not that bad, was it? You guys agree? Not bad at all. Okay, so homework. Let's change it because you don't have a